Let's go ahead now and look at how to balance redox equations with the ion-electron method. In your introductory classes, you learned how to balance equations by inspection, where you looked at the number of atoms on each side and tried to use coefficients to make them the same. That doesn't work when you're looking at the net ionic equation, which is the real chemistry sometimes. So we have a process called the ion-electron method to help us. Redox takes place generally with hydrogen ions floating around in the solution, which makes it acidic, or with hydroxide ions floating around, which makes it basic. So we have a process for balancing an acid and one for balancing a base. We'll go through the acid first. So when we have free hydrogen ions in the system, we follow these rules for balancing the equation. We start off, we write the skeleton equation. Now for this class, the skeleton equation will often be written for you, and it's generally ionic. Then we divide it into half reactions, an oxidation half and a reduction half. We balance everything except hydrogen and oxygen by inspection. To balance oxygen, we add water to the side that is deficient in oxygen. We add hydrogen ions to the side that needs hydrogen because it's deficient in hydrogen. Then we add electrons to make the more positive side so that we balance the charge. The charge has to be the same on both sides. It does not have to be zero. We make the number of electrons in each half reaction the same. Then we add the two halves together and cancel out what appears on both sides. Now, you look at that and it's like, what? It makes no sense. So we're going to go through this example stepwise. On this first example, I am going to rewrite the entire equation at each step. Normally, I don't do that because it takes too long. But I'm going to go through this one stepwise so you can see the process. Then I'll do one more before I have you try some. So we look at this. Permanganate plus sulfurous acid yields sulfate plus the manganese ion. And I want to start by dividing this into two half reactions. So I look for the non-oxygen or hydrogen species that are the same on the reactant and product side. So I have a permanganate ion contains manganese, and the manganese ion contains manganese. So that makes one half reaction. So I write permanganate yields manganese. And that is my first half reaction. Then I see what's left, and I see the sulfur half is left. Sulfurous acid yields sulfate. So now I choose one half reaction and I start working on one half. And then I'll go back and do the other half. Doesn't matter which one you do first. So I balance anything that's not oxygen or hydrogen by inspection. One manganese, one manganese. Now I look at oxygen. 4 oxygen, no oxygen. So I will add 4 molecules of water to the right-hand product side because that's where I need 4 oxygens. Now my manganese and my oxygen balance, but I look at my hydrogen. I have 8 hydrogens on the right and no hydrogens on the left. So I will add 8 hydrogen ions to the left plus my permanganate yields manganese plus 4 water. Now I look at this and I evaluate it for charge. I have a plus 8, 8 times a plus 1, and a minus 1, that gives me a positive 7. Over here I have a positive 2. What's the difference between plus 7 and plus 2? Is 5. So I need to add 5 electrons to the more positive side, which is the positive 7 side. So 5 electrons plus 8 hydrogen ions plus permanganate yields Mn2 plus 4 waters. Now at this point, I should have a balanced half reaction. At this point, you need to stop and evaluate this and decide, is this indeed balanced? So you stop and check here. 8 hydrogens, 4 times 2, 8 hydrogens. 1 manganese, 1 manganese. 4 oxygens, 4 oxygens. Negative 5 plus 8 is a plus 3, minus 1 is a plus 2, plus 2. So I am balanced, so I can leave that one alone. Now I'll work on the sulfur half. 1 sulfur, 1 sulfur. 3 oxygens, 4 oxygens. So I add 1 water to the left-hand side where I need oxygen. So water plus sulfurous acid yields sulfate. Now I'm balanced for sulfur and oxygen. I check my hydrogens. 2 hydrogens and 2 hydrogens is 4 hydrogens. Over here, no hydrogens. So I add 4 hydrogen ions to the right-hand side. So water plus sulfurous acid yields sulfate plus 4 hydrogen ions. Now I look at the charges. Water and sulfurous acid are neutral. 0 charge on the left. A negative 2 and a positive 4 is a positive 2. So I add 2 electrons to the more positive side. So water plus H2SO3 yields sulfate plus 4 hydrogen ions plus 2 electrons. Now again, I want to stop here and check and make sure this really is a balanced half reaction. 2 hydrogens and 2 is 4, 4 hydrogens. 1 oxygen plus 3 is 4, 4 oxygens. 1 sulfur, 1 sulfur. 0 charge, plus 4 minus 2 minus 2, 0 charge. So I haven't messed this up yet. There's a lot of places to run amok. Now, the next step is to make the charge the same on both sides. So to do that, I look at the number of electrons on each half reaction. We're making the number of electrons the same. I have 5 electrons here and 2 electrons here. So I'm making like the least common denominator. So to do this, I will multiply my reduction half. Reduction is gain. The electrons are being gained. They're on the reactant side. I'll multiply this by 2 to give me 10 electrons. And I'll multiply the oxidation half by 5. Then I can add them all together. So when I multiply this by 2, 10 electrons plus 16 hydrogen ions plus 2 permanganate yields 2 manganese plus 8 waters. Now I'll multiply the other half by 5. 5 waters plus 5 sulfurous acid yields 5 sulfate plus 20 hydrogen ions plus 10 electrons. Now hopefully I didn't mess up there, but if I did, I'll see it in the next step. Now we add these together and then we cancel out what appears on each side. So I'll add all the reactants together. 10 electrons plus 16 hydrogen ions plus 2 permanganate. That's the reactants from the first equation. Plus the 5 waters plus 5 sulfurous acid yields 2 manganese plus 8 waters. No. Oh yeah, that's right. Okay, plus 5 sulfates plus 20 hydrogens. I was thinking I should be multiplying, but I already did that. Plus 10 electrons. Now I look at this and I say, what appears on both sides that I can cancel? Well, I can cancel 10 electrons from each side. I have 16 hydrogen ions here, and I have 20 hydrogen ions on the other side. So I can cancel 16 hydrogen ions. That leaves me 4 hydrogen ions on the right. 2 permanganate, no permanganate. 5 waters, 8 waters. I can cancel 5 waters, leaving me 3 on this side. So now I'll rewrite it looking at what's left. 2 permanganate plus 5 sulfurous acid yields 2 manganese plus 3 waters plus 5 sulfate plus 4 hydrogen ions. Now, with all that scribbling around, you can see where it would be easy to miss something as you're rewriting this. That's why you always stop and check. So now I should have a balanced equation in acid. 2 manganese, 2 manganese. 2 times 4 is 8 oxygens. 5 times 3 is 15 plus 8 is 23. 3 oxygens, 5 times 4 is 20. 3 plus 20 is 23. 10 hydrogens, 6 hydrogens plus 4 is 10. 5 sulfur, 5 sulfur. So I'm balanced for mass. I have a negative 2 here, no charge there, so a negative 2 on this side. Plus 4 minus 10 gives me, plus 4 minus 10 plus 4 gives me a plus 8. Minus 10 is a negative 2, so I'm balanced for charge. So always stop and check to make sure you've balanced for mass and charge. It is possible to have one and not the other.